Hi there, welcome back to Road Tutorials. In today's tutorials, we're going to learn about how to use constants and buses, ranges, and swizzling. So let's see how we declare a constant. To declare a constant in road, you have to use the keywords like constants explicitly defined using the constant keywords, which extend logic, by the way. So, and then what's the value of a constant in integers? For example, 5. And then you have to give the width of your constant as well. For example, this example give the width of 16. So let's see how we can do that in our workspace. Go back to our workspace, clean out everything. So let's try to declare a constant like a equal to constants. We want to use the constant keywords. And then what is the value of a constant? In this case, it's going to be, let's say, 5, like the example, and then the width, give it 10, and just print out what's the value of a. So it had a width of 10 and hexadecimal value of 5, right? So in this case, right, we notice one thing here. We don't need to use put to deposit our signals. It's already have a constant value of 5 in our a. So yeah, so that is how we declare a constant in road. So the next thing is pass ranges and swizzling. So now in this example, we have like a signal A to F here. As we can see, A and B is the usual logic signals, and C is a constant of value 7 with a width of 5, and D is also the norm common signals, and E, look at the width of the um, logic E and F. Here, D, C, and A is used D dot width plus C dot width plus A dot width. Okay, so D, C, and A, right? Notice that in logic, if you use dot width, you can actually get the width in integers of a certain logic. For example, D dot width is going to get 1, C dot width is going to return 5, and A dot width is going to return 4. So add together, 5 plus 4 plus 1 is going to be 10, right? Okay, so same goes to F. So let's check, just copy out this code. We're just going to exercise it in our workspace. Okay, just clean out the constant example just now, save it. So to assign a value in road, um, let's say we want to get certain bits position in B. So let's deposit some signals to B first. Yeah, so we can actually deposit binaries value. Just use the keyword bin here, and then it's a 8-bit. So let's deposit 1111 000. Okay, so we deposit B, and then let's see, we want to get the value of this bit. It's going to be 0, 1, 2, 3, 4. Okay, so B4 dot value dot toInt. Let's see whether it will return 1. Yep, it's returned 1. How about value of 0? It's going to be returned 0, right? Yep. So this is how we access a certain bits position in road logic. So let's try to assign this D to, let's say, B4 just now, and then we assume that D is going to be 1 as well, right? Let's run the code, and we expected to see 1. Yep, so as you can see, this is how we actually assign a certain bits to another logic signals. Okay, so the next thing that we want to experiment with is how we can actually use swizzle. Here, let's say we want to swizzle 3 signals and then assign it to a signal here. Let's see this E. Let's see swizzle. Let's assign E to the value of D and then C and then A. Then we can use swizzle to swizzle up all the signals together. By the way, swizzle is just to merge everything together. Yeah, just think of it that way. Okay. So what's the value of D? What's the value of D? D is 1, right? And then how about I'm just going to label it. Oops, should be two strings. Yep. And what is value of C? We don't, it's a constant of 7, right? So we can just print out C is going to be C dot value dot toStrings, then include with made to false. And what's the value of A? toStrings include with to false. Alright. So before I forget, let's just quickly deposit value A to binary of oops 0000. Alright. So when we swizzle out, we can just see the value of E here. Alright. So let's run the code. Okay. So here we can see that E is the combination of D. So what is D? 1. And what is C? 0, 0, 1, 1, 1, 0, 0, 1, 1, 1. And what is A? 0, 0, 0, 0. So it's going to be 0, 0, 0, 0. And there's another ways of doing that. In this case, let's say we want to swizzle it reversely, we can use R swizzle. So let's use R swizzle to F. So let's say D, C, and A, and R swizzle. Alright. So just put F, F. Alright. So let's run code. Okay. So as you can see from here, this D, value of 1, we're going to put reversely to here, 1, and then by C. So C is 0, 0, 1, 1, 1, 0, 0, 1, 1, 1 will be added. And then the last one is A, 0, 0, 0, 0, 0, 0, 0, 0 will be added here. If we're going to swizzle reversely in this case, yeah, so just feel free to use swizzle or R swizzle based on your use case. Will provide a flexibility for that. Alright, so let's continue to the tutorials. So basically we learn about swizzle, R swizzles, and yeah, another thing is slice. We want to look into slice, right? Let's see how, let's say we have F here. Let's see we want to slice these bits here, 1, 1, 1. How we can do that? So we can use a function called slice. So slice of E. Okay. Say E dot slice. What is the index of 1, 1, 1? It's going to be 0, 1, 2, 3, 4. Okay, 4, 5, 6. 4 to 6, right? It's going to get us 1, 1, 1. Alright, E dot slice and then value sorry, dot value dot toStrings include with false. Alright. So 111 as expected. So that's how we slice a value in root. So let's continue. And then you root does not support assignment to a subset of bus. That is, you cannot do something like E3 and then assign to D. But instead, you can use with set function to get a copy of that subset of bus assigned to something else. This applies for both logic and logic value. For example, you want to reassign variable E to a new logic where bit 3 is set to D. So, for example, E here, look at this E. So, you want to assign at position 3, you want to set this E with value of D to that position. So what does that mean, right? So let's see here. So for example, this E, right? E have a value. E have like 100, 111, 0000, right? Yeah, so we can use E dot with set, and then what is the index here? So let's see. E, let's say we want to put this index 0, 1, 1, 1. We want to update this index to value of D. Let's say 1 here. Okay, so you will notice that you say that final variable E can only be set 1 because we are using equal operator in Dart. So that's why this E, instead of final, we have to use var here. And then we can now print out the value of E. That bit position E 1 to D. Yep, it's going to be something like this. Yep. So we can see from here, from E is 100, 111, 0000, 100, 111, 000 become 1 here. You can see the bit position of 1 is become the value of D right now. Yeah, so this is how you set a variable in root to a specific positions. Yeah. So until then, happy coding.